Hello everyone. Today we'll continue developing various machine learning models, but before we do that, I would like to briefly go over what we'll cover today and in the remaining sessions of this program. And actually, I have sent you an email regarding this that provide detailed outline of what will be covered in future sessions of this program. So let's review this email together now and discuss what we'll do in the future in the remaining sessions. So we will continue working on different ensemble models that we didn't cover in the previous sections. Last Thursday we have covered some of the ensemble models, specifically bugging ensemble model, the first bugging ensemble model, which is random forest. So we'll continue other bugging ensemble model, which is extra tree today, as well as boosting ensemble model that we have discussed during the first part of this training program. So we will see how we will train and test and evaluate different ensemble models that we didn't cover before. And on Thursday we will focus on neural network. We will see how to train and test neural network for the same problem. Then next week we will introduce physics-informed machine learning or physics-informed neural network, or PIN for short. This is, as we said, this is a technique to incorporate physics laws into a machine learning model. Sometimes, as we said, machine learning model being purely data-driven, sometimes produce results that violate physics laws or domain knowledge. So to overcome this, we can incorporate physics laws into machine learning model. So we will introduce, we can do this by using PIN or physics-informed machine learning. So we will introduce and see how to do that in the next week. After that, we will train several machine learning model specifically for classification problem. And now what we are doing is for regression problem. So we will train several all of the machine learning models for the classification problem as well. We'll see how to do that. And there will also be a capstone project that will be shared in Google Classroom. And finally, there will be an event for a final conclusion and a certification program. So also the recording for all sections in part 2 are available in Google Classroom, and the link to each section is also shared in this email. And at the end of the email, there is a link to anonymous feedback. So as we covered more than half of the training program, you can start completing to complete this anonymous feedback. So we expect that you all please complete this anonymous feedback, as it will help us to improve this training program, especially for future training. So it is general feedback about the training program, and there's one point I would like to discuss, that is potential topics that you would like to be covered in the future training. And the first one is explainable AI and the model interpretability. As we discussed before during the first part of this training program, we said complex machine learning model that are that we use for solving real world problems are often referred to as black box because it is hard to understand how they generate specific predictions or outcome. However, there are some techniques recently that can be used to explain to some extent the output of machine learning models, and these techniques are called machine learning explanatory techniques. So we can discuss how to about explainable AI and the model interpretability, and what are these algorithms and how to use these algorithms. This can be one potential topic. And Another topic is generative AI. As you can understand from its name, generative AI is an AI that generates new content. This content can be text, can be numbers, can be image, audio, or video. We can discuss about generative AI algorithms and how to use them, and especially when you have limited data for training machine learning model, or when the problem that you are working on has limited real data or experimental data. For example, you can use generative AI to generate synthetic data and then merge both to train and test machine learning model. Because as we said, as we discussed, machine learning models require large number of data to develop machine learning model. So you need to have adequate number of data. So, but when you don't have large number of data, you can use generative AI to generate synthetic data and merge with existing small number of real world data to train machine learning model. For example, one of these generative AI is conditioned tabular generative adversarial network. We can use this, or simply it's called CTGAN. So we can use this to generate synthetic data that can be used to train machine learning model. And actually, I have shown you an example. I discussed one of the studies in which I used CTGAN, or conditioned tabular generative adversarial network, for generating synthetic data, uh, and then that data in which that data is then used for training machine learning model. So, and when this generative AI generates data, synthetic data, we need to evaluate the reliability of generated data to make sure they resemble actual data or real data or experimental data. There is a technique to do that, and to test its reliability to make sure they can be representative data. So we will discuss about that technique as well. So this is another potential topic to be covered in the future based on the need. Another topic is natural language processing and the large language model. Another topic can also be AI-powered multi-objective optimization for various applications. When optimizing, conflicting objectives, multiple conflicting objectives, such as, for example, reducing costs, reducing and improving sustainability of a product, or reducing environmental impact, and at the same time increasing the performance, reducing energy consumptions. These are conflicting objectives. So in this case, conventional approaches are often not capable to do that. So however, we can use AI and merge it to integrate with multi-objective optimization algorithm to for this type of task, to efficiently optimize multi-objectives and come up with an optimal solution that balances, for example, in this case, cost, energy usage, environmental impact, as well as performance of that product. So, and actually, I have also discussed one project of mine in which I used AI-powered multi-objective optimization algorithm to come up with a concrete mixture that is cost-effective, environmentally sustainable, and ultra-high performance that can be tailored to specific project requirements. And I have also shared that paper in Google Colab, so as a reference, so you can read that paper as well. Anyways, this is also another topic, very interesting and important topics in many cases, and we can cover this as well. Another topic is transfer learning, control learning, and the domain adaptation. And this is actually transfer learning, as the name indicates, is transferring a knowledge from one problem to another problem. So in some cases, again, when you have limited database for a problem that you are working on, and if there is similar problem, not exactly the same, but similar problem that has more database, then we can train a machine learning model on other problem that is related to your problem that you are currently working on, and transfer the knowledge from that problem to the new problem. This is also very interesting and a powerful machine learning technique. So we can cover transfer learning, continual learning, and domain adaptation. That can be other potential topic for future training. And another potential topic is AI for time series data. So how to use AI, develop AI model or machine learning model for time series data. Another topic is for image database. What we are covering during this training program is for quantitative data, but how about when we want to use image data to train machine learning model and use it for for new data for prediction of new cases. So that's another interesting topic that we can cover. And another one is for recommendation algorithms, developing recommendation algorithms. Other one is for clustering algorithm and applications. Clustering is unsupervised machine learning. We have discussed about unsupervised machine learning and the different types of unsupervised machine learning, including clustering and dimensionality reduction. And under clustering, we have discussed different algorithms that can be used for clustering, but we will not in hands-on training part. This was covered. This was covered on under part one, which is conceptual part, but on hands-on training, we will not due to time limitation. We are not going to cover it. So, but it can be covered for future in future training. So, if you want it to be seen in future training, you can also select this one. And another one is advanced hyperparameter optimization algorithms. As I said before, again, the hyperparameter optimization algorithm that we are using in this training program is grid search and random search. We have seen how to use both on Thursday and on previous sessions. So, uh, however, there are other advanced parameter optimization algorithms that are more efficient, and one good example is Optuna, which is considered as next generation of parameter optimization algorithm. So we can cover this one as well. And again, I have shared with you in Google Colab some of my papers, published papers in which I have used Optuna. So you can read that as well. But this is another good potential topic that we can cover in the future training. Another one is when we develop machine learning models to be more practical and useful to others, especially practitioners, useful to practitioners and decision makers. We need to deploy that model as a graphical user interface based software tool. So we can see how to do that. That we can train a machine learning model, test it, and then deploy it to a software tool. So we can see how to do this as well in future training. And if there is any other topic that are not covered, not listed here, this list is not exhaustive. So if there is any other that you would like it to be covered in future training, please just select other and list them here. So you can select multiple options here. So all of those that you would like to see in future training, please select them. And if there is any other not listed here, you can again, as I said, write it. And as I said, this feedback is anonymous. However, if you are comfortable, we would like to post, a summary of your feedback on the training program website. So if you are comfortable to put your name on your feedback along with your feedback on the training website, please select yes, I am comfortable, and provide a summary, your name and a summary of your feedback, and we'll be very thankful for that. However, if you are not comfortable, you can just select no, I prefer to remain anonymous. So with that, uh, let's uh, let's get started with today's section. Uh, Google, I will I will go to Google Classroom and start working on the Google Colab that we are working on. This is again, as I said before the end of each section, I mean before the beginning of each section or start of each section, please make sure to download the latest Google Colab notebook that we are working on. It's found in Google Classroom. This is the one.